Welcome to this video lecture on the subject transmission lines and antennas. So in this lecture we are going to discuss about critical frequency, MUF and skip distance. First of all, let's see the concept of actual height and virtual height. It is used in the concept of skywave propagation. So first one is the virtual height. The incident and refracted rays follow the path that are exactly the same as if reflection take place from a surface located at a greater height. So it is called as the virtual height of this layer. So on the actual height, the actual path of the wave in the ionized layer is a curve and it is due to the refraction of the wave. So this height from this curve to the earth surface is called as the actual height. So next is the critical frequency. So the critical frequency of the layer is defined as the maximum frequency that is returned back to the earth by the layer when the wave is incident at an angle 90° to it. So critical frequency of F2 layer is between 5 to 12 MHz. So this value is not fixed, it depends upon the electron density of the ionosphere. So the critical frequency changes with the time of the day, atmospheric condition and the angle of fire of radio waves by the antenna. So the existence of critical frequency is the result of electron limitation, that is inadequacy of the existing number of free electrons to support reflection at high frequencies. Critical frequency is the highest magnitude of frequency above which the wave penetrates the ionosphere and below which the wave reflected back from the ionosphere. So critical frequency as a function of electron density, Fc equal to 9 square root of n max. N is the maximum electron density per meter cube and critical frequency is in hertz. So as a function of maximum usable frequency, it is given by Fc equal to MUF multiplied by cos theta, where theta is the angle of incident. And relationship of critical frequency with plasma frequency. So it is related through plasma oscillation concept by using this omega relation, which is equivalent to n into e square divided by m into epsilon naught, where omega is given by 2 pi f and fc is equal to 8.979 square root of n max. It is around equal to 9 square root of n max. And relationship with the index of refraction. So the using the values of for electron charge, permittivity of free space and electron mass, and angular velocity with respect to f. So it is given by n, relation of n, it is equal to square root of 1 minus 81 n divided by f squared. So it is related with critical frequency and index of refraction. Next, critical frequency and the F layer of the ionosphere. All long distance high frequency radio communication use the high frequency radio waves that are obliquely incident on the ionosphere. If the high frequency is above the critical frequency, the radio signal passes through the ionosphere. The critical frequency changes continuously and the F layer of the ionosphere is mostly responsible for the reflection of the radio waves. The other layers interact in other ways. Absorption of frequency during the day, the D layer forms and the F layer splits into F1 and F2 layers. Next is the maximum usable frequency. In radio transmission, maximum usable frequency is the highest radio frequency for a transmission between 2 points on the earth by reflection from the ionosphere at a specified time independent of the transmitter power. So this index is useful for shortwave communication. So MUF is given by the relation critical frequency divided by cos theta. So the ionization of atmosphere varies with time of the day and season as well as solar condition. So the upper frequency limit for skywave communication varies. MUF is the median frequency defined as the highest frequency at which the skywave communication is possible 50% of the days in a month. as opposed to the lowest usable high frequency. So, which is the frequency at which the communication is possible 90% of the days and the frequency of optimum transmission. Next is the skip distance. The skip distance is defined as the shortest distance from the transmitter measured along the surface of the earth at which the skywave of fixed frequency returns back to the earth. The frequency should be greater than the critical frequency. So it is kept constant by adjusting the angle of incidence in such a way that wave returns back to the earth, and MUF is the frequency which makes the given distance corresponding to skip distance. So this frequency should be greater than critical frequency. So these are the assessment questions. First one is the maximum possible frequency for which the wave is reflected back for a given distance of propagation of ionosphere layer. So the answer is maximum usable frequency, and skip distance is the minimum distance at which the wave returns back at the critical angle. Thank you for listening this lecture.